All right, congruence and transformations. A transformation is a change in the position shape or size of a figure. The original figure is the pre-image and the transformation is referred to as the image. In this section, you're going to be given a translation rule and a set of points. And what you're going to do is apply the rule, the transformation rule, to the existing set of points, and you're going to write a new set of points. And then based on what rule you were given, or what you were asked to do to the coordinates, you will determine if it was a translation, a reflection, a rotation, or a dilation. Okay? So before we transform any of these shapes, look at the table in the middle of page 217. And it talks about the transformation and then the coordinate mapping and description. So we'll call it mapping and description. So let's talk about a translation first. The mapping rule for a translation, or translation is also referred to, or I remember it as a slide. Okay? The image either goes to the right or to the left, or it can go right and then up, right and down, left and up, left and down. It's just where you take the image and you slide it on the coordinate plane. Its size stays the same, but the image just gets moved. By a rule, it gets moved. So this would look like for each xy, we're going to translate it so that x is going to be added to by a units, and y is going to be added or subtracted by b units. Okay? And put plus or minus here. Plus or minus, plus or minus. We'll do some examples of these in a second, but I want you to have these rules down first, so that if you see a translation rule, or if you see a transformation rule, where all the x's are going to be, let's say that for each xy, you're going to translate it, you're going to add 2 to all the x's, and you're going to subtract 1 from all the y's. Okay? The x-axis is the horizontal axis, right? And the y-axis is the vertical axis. So if you take this shape and you add 2 to all the x values, where are you shifting it? You're moving it to the right 2 units. And then if you subtract 1 from all the y values, it's going right 2 and down 1, isn't it? Okay? So when you're adding or subtracting all the same value to the x's, and you're adding or subtracting all the same value to the y's, it's a translation. Okay? In a reflection, the rule would look something like, for each xy, your new x value will be the opposite of x, and your new y value would be the same as the original y. Now this is a reflection, this is an example of a reflection across the y-axis. The transformation rule, where you take each xy and you transform it by keeping your x value the same and making all the y values the opposite of the original y, that's a reflection across the x-axis. Rotations. When each xy value is transformed and you look at this rule, for each xy you're going to transform it, so the new x value is going to be the existing y value, and the new y value will be the opposite of the original x. That is rotation, and that is 90 clockwise. 90 degrees clockwise. When you take all of your xy values of the pre-image and you transform them so that your new x value will be the opposite of your original y value, and your new y value will be the existing or the original x value, this would be a 90-degree counterclockwise rotation. And the third rotation that we'll talk about is when all of your xy values of the original image just get multiplied by -1. That is a 180 rotation about or around the point 0, 0. All right, and the fourth transformation is a dilation. And that rule would look like each xy is going to be transformed so that you multiply, this k would mean a constant times x and a constant times y. K would have to be greater than 0. And this would be a dilation with scale factor k and a center of 0, 0. So can you imagine an image or a figure, and you took all of the x values and you multiplied them by 2, and all of the y values and multiplied them by 2? That would be a constant, right? What would the scale factor be in that case? 2. All right, if you multiply all the x values by 2 and all the y values by 2, that makes your scale factor 2. All right, would the image, you think the image would get bigger or would it get smaller? Yeah, it seems like it would get bigger, wouldn't it? What if your scale factor, or what if your constant was 1/2? What would the scale factor be in that case? 0.5 or 1/2, right? So whatever you're multiplying the x and the y by is your scale factor. So if your scale factor was 1/2, you're going to be multiplying all the x's by 1/2 and all the y's by 1/2. Your scale factor would be 1/2, and the image would get smaller, wouldn't it? Make sense? Okay, what you're going to be given today is, take a look at example 1 on page 216. And it says, apply the transformation M to the polygon with the given vertices. Identify and describe the transformation. So here's what you're given. You're given M as, for each xy, you're going to transform it x plus 2, y minus 5. And then you're going to be given some points, or the coordinates of the pre-image. P is at 1, 2. Q is at 4, 4. And R is at 4, 2. Now, here's the notation you're going to use after the transformation. P is at 1, 2. The new P is going to be called P prime. Its coordinates are going to be 1 plus 2, which is, and 2 minus 5, negative 3. So P prime is located at 3, negative 3. Q prime.
Is that supposed to be a 1?
No, that's what?
On top of the Q.
It's the symbol for prime.
Oh.
It's a notation. 4 plus 2 is 6, and 4 minus 5 is negative 1. R prime. It will be located at 4 plus 2, which is 6, and 2 minus 5, negative 3. Okay? So this original coordinates, that's your pre-image, isn't it? After you apply the transformation rule, you have the coordinates of the image. And those are denoted with the prime symbol. Second part of the question is identify and describe the transformation. Well, what type of transformation was that?
Translation.
It was a translation. Good. Translation. Right, how many?
2.
Right 2,
And
down 5. It is kind of simple. It's just a matter of seeing the notation and then being able to apply the rule to choose what transformation occurred. Let's apply this rule for every xy. We're going to transform it so that the new x is the original x multiplied by -1, and the new y is going to be the same as the existing y. You got a is at 1, 1. B is at 3, 2. And C is at 3, 5. So A prime, the rule says multiply x by -1 and leave y the same. So it would be -1, 1, right? And B prime would be located at, and C prime. You took all your coordinates and you just made the x coordinate opposite each time, didn't you? So what kind of transformation was that?
Reflection.
Very good, reflection. Where?
Across the y.
Very good. You went across the y-axis, didn't you? Because the y's stayed the same. Reflection across y. We'll say y-axis. A reflection across the x-axis would be if all the x's stayed the same and the y's changed, right? All right, so let's do one more. Top of page 217, example D. The rule is for every xy, we're going to transform it so 2x, 2y. K is at -1, 2. L is at 2, 2. And M, 1, 3. So where's K prime? -2, 4, good. And L prime would be located at 4, 4. And M prime, 2 and 6. We say this is a dilation, right? With scale factor. What's the scale factor here?
2.
Very good. Scale factor of 2. That's it for today. So your practice is going to be on page 220. Three through 6. And then 13 through 18. And please check headline for homework.